First, we need to know what is actually fish eye is. Fish eye is a defect contained in a PVC sheet, and it has a circular shape like this. And in continuing the race, the diameter is between 0.05 millimeters to 0.5 millimeters. And we analyze fish eye analysis. First is normal fish eye, and second is distribution fish eye. As a background, we take a simple test. One sample is rolled and analyzed by one operator, and then analyzed again by other operator. Total, we got 22 data, and this is what we get. The differences between one to other operator. For the normal fish eye, we get max 4 for the result of the analysis. And for the fish eye, we did the same thing, the same test, same number of samples, and we get 640 for the result of analysis. The differences between one and two operators. This is quite big gap between one to another, and we need to solve it. We also did the same thing by using a standard sample. Before we did 22 is a random sample. From PVC1 to PVC2 is random, but with this one, we use a standard analysis, and we get the accuracy about 85.4% for the accuracy for the result. And for the normal fish eye, we get the accuracy 46.9%. Let's take a look why. The material itself, diameter of this fish eye is very small. It is in a micron. And for the sheet, we got light radiation. In the long-term use, it can cause dizziness. For the man itself, the ability of its operator is different because there is young, there is old, there is very old. And the method is done manually because we know eye is very depends on the conditions between day, between night. It will be much more different, and it will tend to have a different result. And that's why the fish eye analysis is less accurate. This is what we try to solve. We set our target that the result analysis is more accurate and precise. There is 3 indicators. First is accuracy of the analysis, second is the standard deviations, and 3 is contact time. At the accuracy of analysis, we got 84.4%, and we targeted into 100%. For the standard deviations, we got 4.9. We target less than 2%. Contact time before is 24 minutes, and we target into 50 minutes. Let's take a look why we need to improve. Because there is a fault in identifying the fish eye. In using the eye, a variation of the age of the operators. And the important thing, there is no tool that's available on the market by laboratory scale that can count automatically fish eye. As the countermeasure, we need to conduct research for standardized fish eye analysis instrument and can replace manual analysis. The result is more accurate. Well, for your info, those kind of devices we already been searched at 1998. And 10 years later, we still do it manually. We still haven't found it yet until 2017 right now. We start from the June 2016, and we able to accomplish it in October 2017. meat theory as the first cycle that we use to conduct the research. We can see at here, this can be imagined as this eye. The light came, and part of the light is absorbed, and other light is deflected. This area that we are going to measure. There is a difference between the light that came before it hit this eye and after it hit this eye. We're using the LDR sensors for the first time inside the device. You can see the correlation here based on the main theory, but the result is no detector response because the sensitivity to light is weak. That's why we decided that we need to replace the sensors. We decided to use the OPT101 because OPT101 is a single detector, a single sensor, but it doesn't have any detectors. That's why we use Arduino Uno. And the second cycle, same principle, same schemes, but different sensors and detectors. For the result, the fish eye is able to detect with only it has diameter more than 0.2 millimeters. And this is the crucial part that we use optic here. This is optical fiber that casts into a resin. The optical fiber end should touch the PVC sheets, and fiber optic tip is easily damaged. Let's take a look. The damage of the tip of the sensors is very fatal to our continuous project, and we decided to not using meat theory again. We try to use image processing, using the cameras as the sensors and a computer to use as a detector. Cycle number 3. This is computer. We use a USB microscope because the fish eye is so small. You need to magnify the light source, and this is the seed. You can see here the image of the image processing. The problem is there is noise also detected. The seed is magnified, but also the substance other than fish eye is also magnified. So we will call it noise. This is in the third cycle, this is also detected as fish eye. Noise is detected very much, and we use one USB, and the analysis time is long, very long. The formation of states on the seed surface, the rolling seed process, the presence of scratch, the roller, and additive effect, that's what we call noise. As a countermeasure, we add a 1.5 carbon black to cover the noise, because we know that fish eye is denser molecule rather than ordinary fish eye. It will not mix with carbon black. To increase the analysis time, we added 4 units of USB microscope. Finally, at cycle number 4, we added the carbon black, same setup, and this is 4 microscope. The result is fish eye can be detected. Good accuracy, automatically calculated, but at the same time, we also capture the image of the fish eye itself. Okay, let's see the summary from the first problem that fish eye is less accurate analysis. Countermeasure is designing the fish eye. At the first cycle, Using our air sensor, nothing happened. The cycle number 2, replace it. We will be able to detect, but optic easily damaged. This is quite crucial, and we determine that we need to change the method using the image processing. Noise is still detected, and the analysis is longer. And cycle number 4, very good. That is our last result, that fish eye can be detected, good accuracy, automatically calculated, and the shape of the fish eye can be saved. This is our tool. The first laboratory scale for fish eye analysis. The only one in the world. Well, actually, this can make a brand value of Asahimas increase in front of our customers. The brand value.
Great.
Let's see the initial conditions and result after SGA. Simple variation.
One and only in the world.
This is an analysis device. We need to validate it. Does the analyzer using the fish eye is ready to use or not? Initial conditions is 85.4% for this. As the result, we can get 94%. For the standard deviations, that for the beginning for 4.9 is we get 2%. And time before is 24 minutes, and we can reach 15 minutes. And this is the normal fish eye. 4 is distribution fish eye. This is normal fish eye. The accuracy is 49%. The result is 92%. Standard deviation is 60%.
Thank you very much for your presentation. Just one point. It was my big impression. You did the trial and error to try to detect the fish eye toward more precisely. But then finally, you utilized the carbon black. Are there some of the trigger you try to utilize the carbon black? Some information from the internet or other? I think it is around the big epoch making. Thank you very much.
Well, actually, that is the biggest problem that we have. That we epochs, yes. If we added the carbon black is added into a fish eye, it will make epoch bubble like, but it's not fish eye. But we make our special recipe. The carbon black is conditionized. We make it more jenuh apa istilah? Saturated. So it doesn't affect the mix when we roll, and it less epoch.